Hello, hi, welcome everyone to this webinar introducing the new version of InSite seismic processing software, InSite 3.18.1. We're going to give a few more seconds to wait until everyone joins us. In the meantime, I just want to introduce this webinar. There is a live chat where you can post any comments or questions that you have, and we will try to answer them at the end of this presentation. So we are going to introduce the new tools that have been, and the new features that have been added to InSite since the last version, 3.18, but also have a quick overview of the software itself, the InSite seismic software itself. Right, so InSite is ASC, Applied Seismology Consulting, seismic processing software that aims to integrate in a friendly using a friendly interface, an easy-to-use interface, integrate data management, processing, analysis, and interpretation for seismic data. It's been developed for the last 25 years, and basically all the tools, all the features within it are part of our internal research and development. It can be used basically at all scales where seismic monitoring applies, from large earthquakes, regional earthquakes, down to acoustic emission events from lab testing, testing on rock and brittle materials. And this last version has been just released. Actually, it was released yesterday in September 2022. So the aim of InSite is to provide tools for the full seismic processing workflow, which includes the setup of a project, the detection of events, that's data harvesting, that is extraction of events from the continuous stream, import of data if it's been pre-processed, the conditioning of the waveforms, that it's filtering, removal of DC, etc., classification of triggers, that it's whether they correspond to actual events, or they are noise or active shots. And once we have the events, complete our processing with the main steps in event processing, that it's such as phase identification, analysis of the frequency content, and probably the most important part, which is the location of the events. And finally, analyze, export our results as an event catalog, or export our processed waveforms. The first part is the project setup in InSite, which involves the incorporation or the inclusion of our seismic receivers, seismic or acoustic receivers, and as an option we could also add any structures, geological or engineering structures, that will help in the interpretation of our results. When we are adding sensors or seismic stations, we have the versatility within InSite to configure them as uniaxial or up to incorporating 4 channels per station. And they can respond to voltage, acceleration, velocity, or displacement. So basically any kind of tool that we can use in our monitoring. And of course, they can be configured in any geometrical setup, such as downhole tools, surface, volumetric, providing a 3D coverage of our volume, or a combination of all of them. Next steps will be, of course, the import of data, which could be pre-processed data or reading the continuous stream. InSite can work with multiple formats, and these are some of the modifications that we have in this latest version. I'm going to show you now. And on import, it creates its own binary file for each of the events that are triggered, which are called the ESF files. We have incorporated two new features, so only one is in this presentation, but we can incorporate two new features in the import of data in InSite in this latest version. And I'm going to open a project. This project has already been processed, but I want to show the import interface for InSite, also the streaming, and we can see the list of formats that it works with. A new format has been incorporated, the BDF, that it's a format used by ELSYS acquisition systems. You can find more information about the ELSYS acquisition system on the website or on our website. Also, we have modified the way segue files are added into InSite, and basically adding these new features, this new flexibility in the import, where we can specify which bytes of our files contain information on the trace number. Because, well, depending on the acquisition system, depending on your setup, some vendors have incorporated this information in different positions within the header. So, by selecting here, we can use the default or inform the software where this information locates. So, this is a new feature in this latest release of InSite. Well, next step is the pre-processing, and pre-processing of the waveforms incorporates the tools or the steps of removing the DC, removing the continuous band of our trace, that it's basically centering our trace around zero. We can incorporate, we can apply a customizable filter, even combine two filters, and the new feature within InSite is the spike removal filter, and I'm going to show you how this works, opening a project in InSite. And this applies to the case which occurs quite frequently, where we have, as you can see here, some very sharp arrivals that do not correspond to the waveform of a seismic event, but rather correspond to electrical noise from our acquisition tools, or could also be natural lightning that has that is affecting our seismic network. So, in order to avoid triggering on these arrivals, we have added the option that we have here for removing these spikes using a hamper filter. Then it's very simply, it's a moving window that takes the average, basically counts what it's the amplitude in that window, and applies the mean to it, to that window. In this way, we are removing outliers. It's a way of removing any amplitude that it's outside of a certain number of standard deviations. So we can change the way it works. We can make it more strict by incorporating allowing a very small standard deviation, or make it more relaxed by allowing a higher number of standard deviations from it. And it applies, basically, when we apply the filter, you can see, let's have a look, for example, at one of these traces where we have a marked spike. I'm going to zoom into it. When we apply this filter, you can see the signal has been smoothed. If I make it more strict, basically, well, what it will do, or I increase the size of the window, it will be more strict and it will smooth our signal further. So this is the way this Hampel filter works, and as I said, the main idea is removing outliers and removing high spikes in our traces. All right, so back to our quick presentation. Well, next step will be the classification of triggers, and that hasn't changed in this version, but basically InSite allows you to label your tool, manage your events, manage your events, and classify them as shots, noise, events, and even create your own category of events if you want to classify them, to label them. That's very simple. In the interface, you just right-click on one event, apply the label that you want to apply to it, or create your own label, and then the software allows you to manage them based on these labels. By managing means you can enable or disable them, or you can also group them based on your manual classification. And then we go on to probably the most useful part of the application, which is the processing of events. By processing, we mean processes such as the identification of our phase arrivals, which can be automated or can be done manually. Normally, you do it manually initially. You can also use your manual picks to inform the software how to identify them, that it's optimize your search parameters so that the auto processing can work more efficiently. And as a next step will be the location of our event. And InSite has the flexibility to use a range of velocity models that includes the most basic homogeneous isotropic for a very quick process, but also it can incorporate anisotropy, can work with layer models, or which is one of the latest incorporations into the software, work with a 3D velocity model built by a series of voxels. There are different inversion algorithms. Each of them work differently in the way that they optimize the solution, such as the collapsing grid search, the source scan, simplex, and Geiger. And just very quickly, how's the logic that most location algorithms work, and especially grid search and source scan within InSite. It's always trying to minimize a residual or minimize the objective function, however we define our residual. And by this we mean the difference in between the model arrival times and source vectors with the difference between them, the model ones, and the observed input that we have. Well, the different algorithms work differently in the way that they optimize this minimum, where they find this minimum difference. Whenever they find this best match in between the model and observed input, then that would be the solution or location of our event. Particularly grid search, what it does is an exhaustive search across a grid, a regular grid. A new feature in this latest version allows you to not to search through an irregular grid. Up to now, you could only use grids that were regular, that were oriented along the northeast and vertical axis and regularly spaced. We have incorporated now a feature which I can demonstrate. I can show you in the software where it locates. It's in the settings where locator and where, if I'm using the collapsing grid search, you can see here we can exclude points from this grid. That's particularly useful if you are working, let's say, with an irregular sample in the lab, or if you are monitoring in the field, if there's a very strong topography and you want to exclude points that fall in the air, basically, that are affected by this topography. So by checking this option, we can incorporate a file, a text file. I can show you basically how it looks like. It will look like this file that we have here. Sorry, it does not show properly. It is a text file. Sorry, for some reason Excel is not allowing me to show it. It's basically a text file that indicates the center of a series of voxels and the dimension of these voxels, which will not be included in the search. And they can be distributed along our volume in any shape. And the reason for this, it will basically accelerate the performance of grid search, and it will also avoid solutions falling in gaps, voids, or in the air. Okay. So these were the new features in InSite, in this new version of InSite. I'm going to go back to the presentation and just discuss basically the other tools within InSite. They've been there for several versions, but just have a quick overview of them. Next step, once we have located our event, will be, of course, the analysis and the export of results in InSite. The results can be exported as a list, as a catalog, which has a list of events with source parameters in them, or as processed waveforms. And there's a series of analyses within InSite. This is just a snapshot of some of them, but basically we can analyze the geometry of the fracture if what we are monitoring is a case of treatment of a reservoir where we want to induce fractures around it. We can get some information of the fracturing process, such as the timing, progression of this fracture, and also the size and distribution of our events. We can analyze the mechanics, that it's by analyzing the source mechanism of our events, we can interpret what is the mechanism that induced that fracture, and a detailed analysis on the uncertainties that we have in our location. Right, so just to finalize this presentation, just to inform you of the different packages within InSite. They all have basically the same tools, but they incorporate specific tools that apply for different applications of the seismic monitoring. So InSite Geo will be the most general version of InSite, and mostly geared towards seismic monitoring of regional seismicity, local seismicity, or even global seismicity. InSite Lab, which is focused, has the tools focused on the processing of acoustic emission events induced in lab testing. InSite HF, which is customized for the processing of microseismicity induced in hydraulic fracturing projects. And InSite Lite, which is a free version, a limited version of InSite that it's offered free for you to explore the different tools. Of course, there are some limitations in them, but allows full processing, basically the import, the visualization of your waveform, and some manual options for processing. And the last package that we have incorporated to our suite is InSite EDU, which also includes tutorials and some demonstration projects that can be used for the teaching in the classroom, for the teaching of seismic processing. Well, thank you very much for your attention today. So, just if you want more information on InSite or any of our services, you can always visit our website, our YouTube channel, which includes all the series of webinars and short videos about the use of InSite, and get all the latest news on our services and products on our page on LinkedIn. Thank you very much for your time, and hope to see you very soon. Thank you.